We have two measurements here with a medium-sized hammer. The top graph here shows impact force applied on the structure in the X and Y direction. One of them is blue, the other is Y, and we superimpose both measurements on top of each other in multi-F window. The bottom graph shows measured vibrations also in X and Y directions of the machine. Next, we click on the coherence. Here, if the coherence is 1, the measurement is excellent. Otherwise, measurement is noisy. For example, because accelerometer cannot measure low frequency signals, and our measurement below, let's say 300 Hz, is not that good. Also, at these zones, the measurements are pretty noisy. Here we have a mode at about 2760 Hz. Next, we look at the spectrum. Ideal spectrum, that means input spectrum or hammer spectrum, must be flat, which is impossible. If the hammer is large, the force will be big, but the spectrum will drop rapidly. For example, a large sledgehammer will have a frequency bandwidth of about 500 Hz. That means large hammers can measure structural modes within 500 Hz. This particular hammer is good up to about 2200 Hz. But we have a mode. The bottom graph shows the spectrum of the accelerometer or vibration. We have a mode at 2325 Hz. But we don't have much strength at this frequency contributed by the hammer. This will create a problem in estimating stiffness of the machine. But within this zone, the measurement will be good. So, in fact, the software tells you, if you look at the broken part starts about 1700 Hz. Then it becomes dotted afterwards, which indicates that the measurement is not reliable after about 2200, 2300 Hz. Indeed, software is warning you about that. How can we capture this mode? That means we can use the medium range hammer from 300 Hz to about 2000 Hz, which typically correspond to machine tool column, bed, structure, and the spindle. Beyond 2000 Hz, usually we have the tool holder and tool only. Then you may have to use even smaller hammer with a harder tip to capture these frequencies. It is possible to divide the frequency range into 3 zones and use different hammer sets if you want to be very accurate. If you are conducting high-speed machining, then the modes beyond, let's say, 400 Hz, they are the ones which will cause a problem. So this medium-sized hammer is good enough for practical reasons.